Hi, my name is Evan Schwartz, and we're going to take a look at the BattleCry prototype. And in the prototype, we're really just looking at the mechanic for creating a game. So we'll start on the Android device, and in this particular instance, I'm acting as Barbara. And you can see I've got a number of games here. I can click on one of Barbara's.
This is a new game.
So basically, I'm able to play or replay the battle cries. So I'm going to have Barbara create one. This is another game.
This is another game.
And then Barbara popped in there.
This is another game.
So that's that one. And I'll put that down real quick and we'll pull up this one. So at this point we don't have the extra Barbara one, so I'm going to do a refresh and you see it pop up here on my iPhone.
This is another game. Creating a game. This is a new game.
There we go. So that's the one you created right there. Probably need to come up with a sorting mechanism, but right now she has a rank of 5. So I'm going to do a challenge on that. Record battle cry. I'm challenging you.
I'm challenging you.
And at that point, that game goes off the list. We'll switch back over here because right now I'm in the sort of open games list. And you'll see that it falls off there as well. And if I go into games, you'll see that it has Barbara, and there's Eddie, which is the guy I thought was somebody else.
I'm challenging you.
And that's what I just recorded in there. So if Eddie comes and looks at his games, and he's only got the one.
This is a new game. I'm challenging you.
And you'll see that you're able to replay both of the challenges itself. And you'll notice that Barbara only got a 5, and Eddie got a rank of 7 with his battle cry. Therefore, the game is showing that it is Eddie's turn. And you see the same thing here.
I'm challenging you.
And that's essentially the mechanic of creating games in BattleCry and being able to challenge them and replay those battle cries. Thank you. Hello, my name is Evan Schwartz, and we're going to take a look at how we put together the BattleCry prototype. What the prototype entails, you just saw that video of it playing on 2 different devices. Essentially, it's the roster where you can create a game, you use your BattleCry to get a ranking, and then you submit that into the list of open matches, and then a challenger can challenge you with his BattleCry or her BattleCry, and then gets a ranking, and the person with the highest ranking goes first in the game. So this is sort of walking through that entire mechanic. What we're looking at here is my Azure account where I have my app service. So I created a web service, a database, and then my service plan, which is just a requirement. So we'll take a look at the BattleCry's website. So we've got the git clone URL. That's really how I deploy it. So we'll be able to see some of that when we go over the server-side application. But essentially, this is the websites or the API's base URL. And then I've got 2 web services, which we'll explore when we get to the .NET side, what I call values, and then cries. The values is basically storing and saving matches, and cries is actually storing the battle cries. So let's take a look at the database and kind of go through that model. I have only 3 tables right now. So this table stores battle, so this manages the entire roster. It's who was the aggressor, who created it, who's the challenger. This will also keep up with whose turn it currently is, so it's going to be A or C or N if it's open. This was the starting rank, and just for my information, when was it created, when was it last updated. And you'll notice that I get an ID here, which is unique identifier. And when I look at my battle cries, it has unique identifier, but it has a game ID, which is a foreign key to that. Turn ID is expansion, so as each player makes a turn in battle cries, the expectation is that they'll use a battle cry to summon their barbarian army, their horde, to do battle from one conflict to the next, conquering territory. and this stores the turn ID, whose cry it is, whether it's player 1, player 2, that sort of thing. And this stores the battle cry, so we can take a quick look at what we've got in there. And right now we've got quite a few of them sitting in there. And this is basically a base 64 UU encoded binary string. Not a lot in here, just some IDs to keep track of it, whose cry it is it the aggressor or the challengers, and of course my created on and updated on. One of the things I like to do with databases is I like to abstract any kind of an access layer or interface layer away from the data model, which frees me up to make changes, particularly as I'm evolving the standard in a game. So these become my interface stored procedures, whether you can call it a CRUD or what have you. It's my read service, my write service, and an update service. So we'll take a look at this one, and they all pretty much the same. So another technique that I like to follow is using XML as a single parameter into a stored procedure, and what that does, that preserves the prototype. So if I need to add additional parameters, I can do so without breaking the prototype, which gives me some future-proofing version control. If I've got older versions of my product out there that are accessing this stored procedure, and it only knows about 2 parameters to pass into it, it still works, right? I don't have to actually add additional parameters. And once again, the product, the game, or the interface tool doesn't really have to know anything other than the stored procedure's name, and it's expecting some XML to come to it. And then the stored procedure can actually reconcile whether or not it's an older version or new version coming in by what is actually in the XML. Can inspect the XML, pull out the parameters, and if a later version is expecting a parameter that's not there, it can fall back to legacy logic saying, well, this must be a call from an older client that needs to run the older code and still be able to support. So this one stored procedure could then support multiple versions, which I like. And it really streamlines the entire middleware piece when development. You only have to touch the endpoints, right? I touch the calling section where I define a new parameter, and I touch the stored procedure where it consumes a new parameter. Now, all the piping in between is untouched. I don't have to do any recoding. I don't have to do any new entity mapping. I don't have to do any of that. I just add an extra parameter to the criteria object, pass it in the stored procedure, and get out what I want. So this just becomes a really simple thing. One of the other things I also like to do is my error logging. SQL Server added big, try-catch logic, thank goodness, and I think in 2005. And ever since then, I've never looked back. So anything that happens in a stored procedure, I capture all the logging, so I know what the procedure's name is by this definition, and I also know the filter data that was passed in, right? So I know all the parameters. So those 2 things right there gives me the ability to rerun this stored procedure with the offending criteria that was passed into it, giving me the best chance at recreating the error and analyzing it and finding out what's going on. And that's what the error log table holds. And I don't know if I've got any errors in there right now. Let's take a look here. I actually do. So on the insert battle cry, I'm getting a conversion failed. This was during some of my testing, failed retrieving game, and then I can always click here and actually look at the data. Now in this case, it's the battle cry, so this is a huge chunk of UU base 64 encoded data. So, but it gives me access to it. So it's really nice for triaging and really trying to figure out what the heck happened down at the data layer. Logging is I'm a huge fan of it. So the other stored procedures are very similar. This is my other for my get games. Pretty much the same thing. What's the game filter? What am I looking for? And manage to select. And the interesting part here is that the calling service, all it knows is what is being sent to it on the select list. So one of the minimum requirements of this strategy is that every call to the stored procedure, whether it's an insert, an update, or a get, always returns something. Always, always, always. So even if I'm inserting data to the database, I want that stored procedure to return to me at minimum an error code and an error message. And that's just confirmation from my calling program that it did what it was supposed to do. And if it doesn't, it captures that error code message. It still sends me an error code, an error message, giving my calling program an opportunity to cope with it and do something interesting with it. And we'll just let's take a look at insert game. I think that's going to be more interesting than insert BattleCry. So here, as you can see, once again, I still have my single prototype. I'm only passing one parameter to it. So every one of my store procedures have exactly one parameter. So the only thing that's interesting about it is the store procedure name. And then I pull out of my XML all the things I want. And this is fairly robust, because if that's not in there, it just sets that to null and I can react to it. So it doesn't blow up because it's not part of the XML schema. So that, again, just makes that very lightweight, convenient, and allows me to add and take away as needed with pretty much impunity. I can really sort of flex and experiment with things, and I always like to keep a little prototype in here so I can run it and test things out. All right, so that's the database at this point. We're tracking the matches, we're tracking the battle cry, so this is the digitized recording of the voice. And that's the SQL Server, and that's the all the setup for Azure. So we'll take a quick break here as I shift over to the Mac side, and we'll walk through the middle layer, the IIS code and Web API code, and then we'll take a quick look at the Unity project and code and how all that was put together, and that'll be the totality of it. Thank you. Hello, my name is Evan Schwartz, and we're now going to take a look at the BattleCry prototype. This is the middle layer server code. So this is all the Web API stuff. So let's take a look at that. Load that up real quick. So it's surprisingly lightweight. I really like the way that .NET has managed their sort of merging of MVC and Web APIs. Not install that right now. All right, so essentially I've got my data models, which are very lightweight serializable classes that, if you recall from the SQL Server, models those tables pretty well. But what they're really modeling is the return set from that database, right? So that stored procedure. So I could really mix up the database however I want, break it apart, create new tables, completely abstracted from the actual database tables. And it comes down to the store procedure and what the store procedure selects. So if I need to break those games out or the battle cries into subtables and stuff, I can easily do that. But this becomes the serializable piece that just gets serialized into JSON and sent back and forth. So I've got two controllers. I've got my values controller and my cries controller. So my values controller is really what's driving the saving and loading of the game itself. This is really boilerplate. I didn't even bother to change the generated version of that, so that's probably something I'll need to do. This is grabbing my JSON app settings. I'm not going to load those up. That's got some sensitive data in it, accessing the database. But essentially, this is what's driving my data handler. So I've got a list of battles. These get passed in as JSON. I get up my database connection. This is me setting up my criteria. Oh, in this get, I don't have anything passed in it. Excuse me on that one. So this just gets called in as a standard get. This is sort of returning everything. The store procedure itself is not filtering anything other than just give me open. That's sort of the default behavior. This doesn't even really get called in the game. I just created this for completeness sake to have it here. As you'll see that's the store procedure name it's calling. This is my XML data criteria object where I'm setting up my parameters and the values, and then I'm calling my sproc. I'm getting my data set, and then I'm filtering through it. And so in this point, I'm extracting what's coming out of that stored procedure, and I'm loading up, as long as the error code is 0, I'm loading up my model class and adding it to a list. If I have an error, then I'm setting up the same thing because the calling program is expecting a battle array to come back, right? So I'll load up and put all of the errors inside a battle object because these are just strings, and I can test for various error codes if I need to from within here. And it still sends it, and then the calling code will cope with that. So here's one that's actually used in the game, that's the example stuff, where I'm passing in an ID, which is really just going to be a filter, right? So as you can see here, here's my game filter, an ID, and it's a text string. And that's ultimately going to be either the name of the player or give me open matches. And it pretty much does the same thing. So the only significant difference between those two is the passing of the ID, goes through the dataset return, builds my battle array, and then returns those as a list of objects, which basically get wrapped into a JSON serialization and sent out the door. The post is a little more interesting. This is where battles are being posted, and inserts on the post is the insert, and the put is essentially an update because it's going to come with an ID and what to update. Similar thing, here's my criteria. Let me grab all of the data relevant to my battle that was passed in, open my data handler, call my store procedure, and then it's a DAG, right? So here's my criteria object here. It's just this is a little XML helper class. These are some helper classes I've built just to, iterate through all of my inner exceptions to getting my error messages if there are any. And if everything is good and copacetic or whatever is returned back from the store procedure, I put that into my error handler, and that's what this is expecting to come back as an error result. Again, that's just a model that I'm passing out. And this is the put side, shockingly similar, except the fact that this is calling the update and this one's calling the insert. Just in case there's any kind of processing, I don't like to commingle these store procedures too much. I want to keep the amount of logic in a store procedure as minimal as I can get it, just from a processing standpoint. And on I'm never going to delete this. I'm going to have a background task that deletes old games or matches that never really get picked up. So that's going to be a SQL job or a job somewhere else. And on the cries controller, pretty much the same thing. In this case, it's pretty much here's my get to get them, and I'm passing in a game ID and a turn ID. And in the instance of beginning the match, right? So no one's actually taken a turn. This is the aggressor challenger battle cries competing to see who goes first. The turn ID is a zeroed out GUID. So it's got a game ID with a zeroed out GUID, and that's how you know that those battle cries are specific to the match itself as opposed to any particular turn. And this gets those cries and returns the cry up. So I'm really getting kind of a specific cry. This always returns both cries for that game in that turn. So my aggressor and my challenger. I might end up making this more efficient because once I wrote it, at the time I built these, I wasn't really sure how I was going to need it or what I was going to need. So, it's sending both cries every time you hit the button. So there's an opportunity for efficiency where I can say, give me the aggressor's cry, give me the challenger's cry. Right? Other than that, very similar process. Set up my criteria object, and I'm passing XML to my insert battle cry, and that's how it saves it. So that's basically the web service piece, and I'm not sure if I've got my terminal window set up. So yeah, essentially I just use my Git GUI. I'm actually in my school Git, but same principle. Let me let this boot up. No, I don't want to do that right now. Find out here real quick. And this, if I had changes in there, it would basically identify them. I can stage a commit, and when I push them into the GitHub on Azure, it actually does all the deployment to my live server. So this is kind of an all-in-one. It gives me my version control, and then it takes that latest version and publishes it to the website. So that's really nifty. Let's see if I can make a quick change here just to demonstrate that construct. And I want to break it here. Just do a quick build. Yeah, it doesn't like that. Well, it's just a warning. It isn't going to kill me. Alright, so let's go back to my Git GUI. Let's do a rescan. It's seeing some changes. Let's stage them. this is a test. I'm going to commit and push, and as it goes through, you'll see that it's calling out to my Azure BattleCry's website and pushing these changes up. And when it gets through the entire push process, you'll see it goes through a deployment phase. There's a little bit of spin up that Azure has to go through. So I guess during development process, because I'm not actively pinging or hitting my web service all the time, I notice that it tends to go to sleep. But if you get past that first little delay and then you start playing with it, it's pretty good. But essentially it goes through all of its packing and uploading, and you'll see here in just a second. Once it's done doing all of its builds, it builds on the server and then deploys. So that's pretty handy, and that really made development of this piece pretty simple, because you can see there's just not a lot of code behind this. The web APIs are such a standard now that you can just, as you saw, I went with boilerplate and started jumping on the code piece to kind of get this pounded out. And as you can see right there, my deployment is successful. So that's good. All right, so we're going to close this piece down. And we're going to switch over here to Unity. In fact, let me close this out. It gets a little buggy here with Visual Studios on my Mac if I've got multiple solutions open at the same time. So I'm going to let shrink this down. And so this is the website. This is the process here. So we'll run it here in the game. Let's make sure I didn't break it. There we go. So as you can see, that took a little bit of spin up time, right, to get that. And let's play that. As it's going out to the various web services. I may not be able to hear these while I'm recording.
You cannot defeat me.
There we go. Yeah, I may just not have had
Creating a game. Except BattleCry.
So as you're clicking on those, you can see it's going out to the website and play. And it does it pretty fast once they kind of spin up. And if I go to my games, you can see I've actually done quite a few of them. And
are you kidding me? Are you kidding me?
And I'm not sure if you guys are able to hear that. I'll check that on the video. But essentially, it's calling out the web service. It's downloading from the database and getting that so that you can hear both of the battle cries. And you can see that it's rank 11 versus rank 59. So obviously, in this case, player Evan goes first. So Evans versus Evans will be a little bit difficult. And this just shows the open games. And this is great. So, and you can create another one, record battle cry, and if you needed to change your user's name and basically create a game as Betty, you could do that, and Betty doesn't have any games, of course. So let's take a quick look at the code and see how that works. So there were a couple of packages I grabbed. One was the Super Scroll view, just to make this very easy to put together, and not a lot amazing in there. And the other one is the Best HTTP Pro. One of the things I beat to death that was just awful was that the built-in HTTP request for Unity didn't support HTTPS very well at all. But this package did a pretty good job. Very affordable, wasn't too bad in cost. But essentially that was the crux of getting that. If you look at here was my original API, and we'll let Visual Studios boot up and take a look at that. So you'll see that I have an insert best API and then post on finish, and then here's get best API, and then here's just the regular get API. So this was sort of the textbook how Unity wanted you to do it, and the only way to get this to work would be to call the base URL as HTTP, which just, I can't even publish that. iOS won't allow you to publish access unless you can go to HTTPS. So that essentially kind of put this dead on arrival, and it took quite a bit of beating and to figure out what was going on. But the best API was quite nice. So here we go. Here's my base URL, and I call values and on request finish, which made it a nice little event. So one of the other things I didn't like about it is that this was a call blocking act. So my UI, when I'm calling out to the web services, stalls while it's waiting for a return. So that was another nail in the coffin for this stuff. This came out really nice. I can pass an event receiver to it, and then once the call completes, let's say open request finished. Here we go. That's this one. So essentially, you get your request object back, and you get your response, and then all you're really doing is you're taking the data that was responded back, put it into a JSON string. JSON doesn't support top-level arrays. It's I noted here that's awful. It's what a pain in the butt that you have to do this kind of shenanigans to make it work, but it is what it is. So I ended up creating a wrapper class that actually wraps the information I'm trying to send back. So I can use my JSON utility to deserialize it, and then basically you will see that I'm grabbing battles from the wrapper of my wrapper class, which is my battles, and iterating over those, and then outputting this to my output text was the original one. So the actual build out, this was just all my testing and stuff, but this kind of demonstrates pretty well how to make it all work. Is in the data sources is where it's all out. Let me see if I can get to on request finish. So this is pretty much the same thing. Download more data. Let's see here. Yeah, do data. So I clear my main list. I do that same request, but you can see right here in the actual game, I'm never just calling the default one. I'm passing in my general game filter, which is controlled by that button. And then it comes here on request finish. Very similar. Here's my JSON response. Here's that awful wrapper. I grab it and turn it into a class. So I basically deserialize it. I iterate over each one of the battles that are inside of it, and I create my item data, and I descend it into my list data. Now this is all the super scrollies requirements. They create the item data. So that's just another structure from my battle structure. I left that in place just because I didn't want to mess too much with the scrolly stuff and cause breakage, and then initialize it and get it to manage. So I have two things, an init and an update later, as we add and take things away to keep it kind of frosty. Everything else is pretty much straight stick Unity code. We've already seen examples of the processing of audio, but I'll go through it one more time real quick like. So on player item data, this is getting my cries, this is posting it, processing the audio, finish A, finish B, that's fine, on play aggressor, on play challenger, play game, and my set item data. So whenever you're playing the aggressors, this is getting the audio back. So that's the left button. This is getting the audio back from the challenger. But this also has the logic of setting up a new challenge. So if there isn't a challenger yet, it's an open challenger. And if you're astute, you'll notice that you can actually name yourself open when you change your name, which will kind of break this logic, and it'll be impossible for you to play a game or get to a point where you can accept a match because you're always creating open games. Essentially, it goes through the creation process where it pops up and you record it, and we'll take a look at that. And this is just, here's an HTTP request where it's a cries, and I'm getting the audio based on the game ID and the turn ID for this particular data item, right? The one that we stored before when we loaded up each one of the items. And then it goes on to its on request finish, B or A, and that probably should have been named A or C, but A is what it is. And basically grabs the data, deserializes it, puts it in a wrapper, and then we process the audio. This is where it gets a little bit interesting. So as we process the audio, we go around to each wrapper that we're passing it in. Here's the battle cries, and then it's for who. So again, remember when I was telling you that right now I'm sending both audios, aggressor and challenger, back to Unity, which is a nice little tweak. I'll be able to get some efficiency out of that once I make that web service a little more focused. And then based on who I want to play, there's going to be two, right, almost always, and it'll go through and it'll find out if I match. then it basically takes that base 64 string, converts it to a byte array. I'm then, having to convert it back to float, unities and level floats, and I use just a block copy to put it back into my float array. And then I create a audio clip on the fly based on my 8,000 samples per second. And then I set that data into my recording, go to my game sound, passing that clip in it, and play it. So that's essentially how I get that audio back from the SQL Server and play it in Unity. Otherwise, the rest of it, it's just wire up to get to the various displays and the the roster itself, and interacting with the roster and all the on-click events for the buttons and that sort of thing. And this is the processing the recording for the aggressor, so it's the same kind of thing. Goes through, here's the JSON request. This is actually creating the game itself at that point, base URL values, and then it does all of its byte arrays, multiplies by 4, blah, 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 codes it, sets up the BattleCry object, basically serializes it, and then calls the second web request. So the way that it's working is it'll create a game, get back its game ID, and then create the actual cry itself and store that. So that's kind of how that is working. Other than that, I think that's the crux of the web service code that we saw, the SQL code, the Azure code, and the Unity code. The rest of this stuff are helper classes that I've used on many other projects that I've leveraged to be able to access SQL Server. This is some of my test code, my models, the item 2, loop list. A lot of this stuff came from the scroller just to manage the scrolling. The salient pieces is this is where the logic is. This is just a challenge pop-up that allows me to do pretty much the same thing you saw the aggressor. I go through, grab the challenger's audio, sets up a game. I have a game at that point, so I'm not really creating a new one. I'm using the existing game ID, and then rather than post, I'm using the put here to save this data. But I still go through the same rigmarole of updating the game and then inserting the challenger's battle cry. All right, well, I hope you enjoyed it. Sorry this was longer than I wanted it to be. If you have any questions, don't hesitate to ask. Thank you.